The last thing we're going to do for this section is take a look at graphing nonlinear equations. Not all of our equations in two variable would be straight lines, and as a matter of fact, most of them are not. Common linear graphs that we're going to take a look at are quadratic, absolute value, and radical, specifically looking at the square root graph. So, graphing quadratics and these other nonlinear equations, let's start by looking at some ordered pair solutions and see how they differ from our linear equations and see if we can identify any patterns. So when we're graphing y equals x squared, again, let's start with some ordered pairs. Start with x is 0. That's a nice easy one to start with. And so we're going to go ahead and say that y equals 0 squared, which is 0, giving us the ordered pair 0, 0. All right, so we've got our starting point. Now let's find another point. Let's go ahead and solve for x is 1 and negative 1. Let's get both of those values. Y equals negative 1 squared, which is 1. Y equals 1 squared, which is also 1. So notice the symmetry that we're going to have with these 2 points because we're squaring them. They give us the same y value. So we have the point negative 1, 1 and 1, 1. So we can see here it's clearly not a linear equation because our 3 points don't form a straight line. We've got this little V shape to start. Okay? Well, let's keep looking at some ordered pairs and evaluate how this is going to change. So continuing beyond negative 1 and 1, let's go ahead and add in negative 2 as well as 2. So y equals negative 2 squared and y equals 2 squared. So we get solutions for both of those as 4. And so again, we have the same kind of symmetry that we saw with 1 and negative 1, but now we have it with 2 and negative 2. So we have the point negative 2, 4 and the point 2, 4. Well, now we see that that V pattern doesn't continue. Now it starts to make a change towards this direction. So let's go ahead and plot one more set of ordered pairs. Let's do negative 3 and 3. Y equals negative 3 squared, that's 9. Y equals 3 squared, that is also 9. So we have these symmetrical points of negative 3, 9 and 3, 9, which we can plot here and here. And so you notice how as we go from one point to the next, the rate of change is getting more and more steep. And that's because quadratic graphs are what's called a parabola, which is a U shape. And so you'll see that the graph actually does this bend as it passes through these points continuously and forms this U shape throughout the graph. So parabolas are going to be a U shape as we continue in that pattern. Now, we call this a parent function. Parent function, and we'll talk more about functions coming up soon. We call this a parent function because all graphs of quadratics have this same U shape. This is the most basic version of a quadratic, and then anything changes to that is going to be a similar shape in a new location on our coordinate grid. So whenever we are graphing an equation that has this x squared feature, such as this here, here we have an x squared feature, we know it's going to be a U shape, but what we have to do is make sure that we find enough ordered pairs to find the U shape, which means we're generally going to need between 3 and 5 points. We have to find between 3 and 5 points at least, a minimum, okay, so at least 3 to 5 points in order to get our U shape. Once we can see our U shape taking place, we don't need to graph any more points. We can just fill in based off that trend. So let's start graphing our next one. So just like before, let's go ahead and start with 0. It's a nice easy value to use. Y equals negative 2, 0 plus 1 squared. Now, 0 plus 1 is 1, squared is 1, so y equals negative 2 times 1, which gives us negative 2. So we have the ordered pair 0, negative 2. So let's go ahead and plot that to start. 0, -2. Now let's go ahead and look at x values to the left and to the right. So we'll do -1. We'll start with that one. And y equals -2 times -1 plus 1 squared. -1 plus 1 is 0. Squared is 0. So we get y equals 0 for our ordered pair -1, 0. -1, 0 is here. And then let's go ahead and look at the point +1. Y equals -2 times 1 plus 1 squared. 1 plus 1 is 2, squared is 4, so we have -2 times 4 to give us -8. So we have the ordered pair 1, -8. Well, here we don't have that same symmetry that we saw before. And we don't have a straight line, and we know we shouldn't have a straight line because it's not a linear equation. So we need to figure out, well, how is this pattern going to continue? We need enough points until we start to see that U shape. Well, what we have here, if you notice, is we have half of the U shape starting to form. So there's no point plotting anything on the right because this is going to continue that pattern. But at some point over here, it's going to have to turn around. So let's find out where it's going to turn around. So instead of finding more points to the right, let's go ahead and find some points to the left of -1 even further. Let's look at the point -2. Y equals -2 times -2 plus 1 squared. -2 plus 1 is -1. 1 squared is 1. So -2 times 1 equals -2. So now we have the ordered pair, -2, -2. Plotted here, and now we see this symmetry here. We have these symmetrical points here and here, so now we see that our U shape is starting to form. Comes up and then comes back down. So we can have a parabola with an upside down U shape. It's still the U shape, just located in a different place on our coordinate grid. And so now we can go ahead and find our last point just to even it out. It should be symmetrical here. We should find a point in line on this side. So let's go ahead and verify that. And we'll start with the point -3 for the x value. Y equals -2 times -3 plus 1 squared. -3 plus 1 is -2. Squared is 4. So -2 times 4 equals -8. So we have the point -3, -8. And there we go. We've got that symmetric point. And now we can see the graph of our parabola. All right, so there are our parabolic shapes, our U-shaped graphs. And you will find that we have a lot of quadratic graphs in our future. And again, when we're looking at the graphs of quadratics, we have to make sure we have enough points in order to identify the U shape.